This is the second part of the cluster analysis. So we will shift to another type of clustering, and this is called hierarchical. So, okay. So this cluster analysis part 2, they talk about the hierarchical clustering. So the differences between hierarchical clustering and the partitional clustering is that this type of clustering is formed by merging individual record that has similar characteristic. So we will keep merging the subcluster to become a bigger cluster until we form a big one cluster. Okay. Compared to partitional clustering, we decide what is K, which is the number of cluster, then we assign the remaining data to the closest centroid. But for the hierarchical clustering, we merging individual item that looks similar, almost similar, that has highest similarity index to form the cluster. Okay, so for example, like this is the hierarchical clustering. So from the top, you can see that the, for example, the data P3 could belong to 3 cluster or 2 cluster, depending on how do you view on top of here. Okay, and the other one is called density-based clustering. So they are based on the density of your data set. They will be forming the cluster. For this one, we the number of cluster is generated automatically based on the density. So you don't have to worry about the number of clusters. Okay. So let's take a look at the hierarchical clustering first. So this one, they produce a set of nested cluster organized as a hierarchical tree. For example, like this, can be visualized as dendrogram or a tree-like diagram. So from as you can see, individual data set here is considered as one cluster. Okay, so every time you go up one level, basically you're merging 1 and 3 first, and then you're merging 2 and 5, and then you're merging 2, 5, 4, and then so on later on until you have one big cluster here. Okay, so that is the process. So when we look from the top, it looks like this. So if you want to have, let me erase this one. So if you want to have 4 cluster here, so the four cluster is over here. Yes. Okay, so this is no. This is the 4th combination. The first combination is this, and then 2 and 5, and then this one. The 3rd combination is that one, and then the 4th one will be this, and then the 5th one is that one. So basically, how do we look at from here if we want to have 4 cluster here? So basically, we have 4 cluster, 1, 2, 3, 4. So this is basically we have combined 2 clusters, so 1 and 2. So that means you have 1, 2, and 3 and 4. 4 cluster. Okay, so based on this dendrogram. So for this one, we do not have to assume any number of cluster. So you can always obtain the K cluster by cutting the dendrogram at the proper level. So this can be used to show the sum of the data that we have, for example, the taxonomies, because at the end you will have something like this format. Okay. So there are two types of hierarchical clustering. So if you go from individual item and then you keep merging them, so this is what we call agglomerative clustering. So they call it HAC, hierarchical agglomerative clustering. So if you going from big cluster and you divide them into two, and then you keep dividing them into two again and so on. So this is what we call the divisive method. So this is hierarchical divisive clustering. Okay. So the basic algorithm is straightforward. First, what you need to do is you need to generate this proximity matrix ataupun distance matrix. So you will let each data point to be the seed ataupun each dataset is considered as cluster. So you will merge the two closest cluster and then reconstruct or re-update the distance matrix. So you will repeat this one until you have a single cluster remain. So the key operation is the computation of the distance of two clusters. So this is very critical. Okay, so we have different approaches to define the distance between cluster. So for example, like this, we start with individual item here. Okay, so each point here is considered as cluster. So we will have P1 up to P, we have how many? 5, 12. So we have up to P12 here. Okay. So this proximity matrix or distance matrix is the measure. Okay, we don't count this one because they are not valid. So we want to find the distance between 0.1 and 0.2, 0.1 and 0.3, up to 0.1 up to P1 to P12. Okay. So once we get this, we find the lowest distance, then we merge them. We keep merging until we find something like this. Okay. Okay, now we want to focus on when we merge them, what happened. Okay. So for example, we want to merge this C25 cluster 2 and C cluster 5. Okay. So what happened to our matrix here? Now we have this. So from 5 to now. Yes. So from 5 times 5 cluster, no, 5 times 5 proximity matrix to 4 times 4. So what happened to the value here? Okay, so what happened to the value here? Initially, we have all the values here. There are some number here, except this. We don't need this. Okay, so there are some number here. So when we combine, for example, we get the lowest value is here. So this is the lowest value. So we take that one and then we combine these two. So we have something like that. So since we have new cluster here, what you need to do is you need to find the new centroid. Based on the new centroid, we need to find the distance between the new combined or the new merge cluster 2, cluster 1, and then cluster 3 and cluster 4. So this is just a mirror. Okay. So this is what happened. Okay, so our task is to find the distance between the newly formed cluster to the other cluster. Then we can complete this table. So once we have the table updated or the matrix updated, which is the proximity matrix, then we can find the lowest value again and merge again. Okay, the issue that we want to address here is the distance between cluster. Okay, how close they are together. So for them, we have few methods here. The first one is called mean. Mean is the distance between two members that belong to two different clusters. Okay, so meaning that these two clusters, the distance between these two clusters is determined by the smallest distance that we can get from two members from two different clusters. Maximum, the maximum distance. Group average means you take all and find the average, or you find the centroid and find the distance. Okay, so the impact of having different intercluster similarity is huge because it affects how effective is your clustering method that we want to use. Okay, for example, like this, we merge them if they are the lowest one. So that means we merge this. No, we merge this one first because this is the similarity. We can have the proximity ataupun similarity, but in this example, we use similarity. So you can see this one, if they are one, that means the higher, the better. So this is similarity matrix. Proximity matrix is the distance base. So the distance for proximity will be 0. So for this one, we take the maximum one. So we combine them, and then the second one and so on. Okay. So how do we actually use this one in our research ataupun work? So we will apply the same data set here, in which we have four documents here with 4 terms. So the first thing that we need to do is we need to construct 4 times 4. Okay, so we need to have this 4 times 4. So this is document 1, document 2, and so on. So this is document 1, 2, and so on. So we need to find this. Okay, so basically we need to find one method. So we need to find 6 values. So these are the 6 values that we have. So the distance 1, 2, 1, 3, 1, 4, and then do 2, 3, 2, 4, and then 3, 4. Okay. So based on this, because we are using distance, so we find the smallest one. So where is the smallest one? We find this one. Okay. So that means we will combine 2 and 3. Merge. Okay. So for this one, we will generate two clusters. So that means we need to form from 4 clusters to become 2 clusters. Now we're combining 2 and 3, and then recompute the center of newly merged. So how do we do that one? Because we're combining 2 and 3, so this one we just take the average. So this one is 1.5, 1.5, 5, 2.5. So this is the new center. Okay. So from here, we find that because we already completed this one, now we want to compute the distance between this to this and this to this. So the newly combined cluster to document 1 and document 3 and document 4. Okay, so we get this one. So document 1 to 4 is 6. So document 1 to 4, the distance between document 1 and 4 is is 6. So we pick the lowest one, which is this one. So that means we will combine document 1 to the document 2 plus 3. So we stop here because we already formed 2 clusters. So basically what we have is this one. So this is 1, 2, 3, 4. So this one is combined first, 2 and 3, and then 1, and then 4. So this is our cluster. Okay. Okay. Any question? Okay. So now we want to differentiate. Just now it's based on the centroid. So now we want to differentiate. What if we use the minimum, the single link? The single link is also called the mean, the minimum distance. So we start with the same process, which is generating the initial proximity matrix. So we choose this one to combine. So 2 and 3 are merged. Okay. So now okay, so we have combined. Let me modify. Okay, document 2 and 3 is merged. Okay, document 2 and 3 are merged to become a new cluster here. Okay, so that means 2 and 3 is this one. Okay, merge. Then we recompute the center of the newly merged cluster and repeat step 1. So that means what is the new center? Okay, the new center is similar to the previous one. Let me get the previous one here. But this is different, right? Yeah, same. So we merge that one and we recompute. Missing something here. So once we get this, so we should be having this. Right? So this is our new center, new data set. So what happened the distance here, 1 and 2, is basically, this one doesn't apply anymore. Oh, yeah, we still have to use this one. Sorry. Okay, so we still have to use this one. We will not use this one. So basically, let me use color. Okay. So now we have combined 2 and 3. 2 and 3. I use color. And then recommend. So we don't have to use this one anymore. And then document 4 to document 3. Okay. Okay, so once we combine them, okay, from here we combine this. Okay, so what left is we have 1 and 2 plus 3 and then 4. Okay, so now we want to find what is the distance between document 1 and cluster 2 and 3. Okay, let me put here. The distance between and document 2. So this one is determining distance between document 4 I may have network problem. Let me do another network. Can you hear me? Boleh dengar? Okay. Okay, so we go back to here. So once we get the first one combined, so now since 2 and 3 are combined, so we want to find out whether we want to use the distance between document 1, 2 or 1, 3. So since we are using minimum distance, so minimum distance, which means that we choose the one that is the nearest, right? So we will use this distance. Okay. And similar to document 4 to the new cluster, so we will use this one. Okay. So that means when we try to find the distance between two clusters, we do not use the centroid. We use the distance of the shortest distance of the between two members of different cluster. So in this case, we find this one and that one and this one. So from these three, we decide, okay, document 2 is nearer to this cluster. Document 1 is nearest to this cluster. So then we combine that one. Okay, so you need to know how do we get the distance between these two clusters. In the previous example, we use centroid, but for this one, we need to find the closest distance between two members from different cluster. Okay. Okay, so for this one, so I copy this one. So basically, since we're combining 1, 2, 3, so 1, 2, 3, so basically we don't need that one. We have that one. Okay. So this is the distance between document 4 to document 1 plus. Okay. So for this one, we choose this one to be the distance. Okay. So this one is, we are looking at the distance between document 4 and this. So the distance that we have is between document 1 and 4. So we will use 6 as the distance. Okay, and merge them. Okay. So that is the scenario here. Okay, the strength of the mean, which is the finding the shortest distance, is that you will be able to handle non-elliptical distance. So basically, for the mean, basically you are looking at the distance between two clusters here, based on the nearest one. Okay. So this one can handle non-elliptical shape, and limitation of this, sensitive to noise, and because over here we have noise. Okay, so we do not know where they belong to, so you will have a mix of here. So you will have overlapping. Okay, so compared to yang tadi this is clean, but if you have noise, you will have overlapping. Okay. Okay, for the next one, we are looking at, okay, for this one, of course, in the beginning, we look at the shortest one. So next one, 3, 6, we mesh with 4. So this one, the shortest is, we take this distance. And then 2 and 5. And then this. So we have two clusters here. So the distance between these two is measured by having that. Okay. So if we illustrate, it will look like this. Let's see. The distance between these two is measured using that one, and this one using that one, and the distance between this and that. Okay, not here. So we don't take the centroid, but the nearest one. So since this is nearest to here, so we will form this cluster. Okay, and if we look at the next one. So the distance between this is measured here. This one is measured that one. And then this one is here. So the nearest is that one. So we have that one. Yeah. So that's how the, oh, sorry, this is maximum, right? So maximum. So maximum is in between the maximum distance. So we have that one and that one. So the distance between this is to here. This is to here. This one is here. This one to here, and this is to here. Okay? So since this is nearer to here, we form this. So now again, the distance between this to this cluster will be that one, and then this one to that one, okay, and this one to this one. So it seems that this is nearer, right? So we combine that. Yep. No, this one, oh, we forgot that one. Okay, so they combine that one. So the maximum will find the maximum distance between two members of different cluster. So this one, the strength will be they are immune to noise and outlier, so which is terbalik compared to minimum. But they tend to break large cluster. Okay, so this one, they bias towards globular cluster. Globular cluster means cluster that looks round. Okay. Okay. To solve this issue, we can also use group average. So basically, we are looking at the average distance between the cluster. So basically, to find the distance between this cluster to this is basically finding the average distance here, finding the average distance of two. Okay, so whichever shortest will be taken. Okay, so for the group, they're less susceptible to noise. So this is solving the minimum, and they bias towards globular cluster. So they have same problem with the maximum distance. So this is how we compare the output of your clustering result. Initially, they will have the same one because, of course, we take the closest one. But as it goes to the next stage, it will take different distance to measure the similarity of the cluster. So that one is similar. Now the issue is, for mean, the distance is in that one, maximum that one, and average would be all. Okay. So it compare with that. Is it different compared to max and min? Okay. So again, the choice of mean, max, and average or centroid will also depends on the quality of cluster produced. Okay, so we need to look at the dBi or the entropy in order to look at the quality of cluster that we have. So if we try to simulate this one using the R software, so first we read the market. So this one we have age and also income, and also the level. This one they put discretization, meaning that they have a different level here. So we have the age and also the income here. Okay. So next one, we perform the normalization because we have different scale for the age and income. So in order to get a good result, we need to normalize them. In clustering, we look at the distance between two objects. So we do not want to have the income to have more influence on the distance. So we normalize both of them. Okay. So once we normalize, we have different range already. So this is the scale for age. This is the scale one for the income. So notice that the differences is minimal. Okay. So we can use this one to perform the hierarchical clustering. So over here we are using the data that we have, and this is the hierarchical clustering, and the method distance is required because the hierarchical clustering works using distance metrics. So in this case, we are using a subset of market data frame. So this is referring to column number 4 and 5. So which is this one. So this is your number 1, 2, 3, 4, and 5. So we are using this data. So this is what happened here, where we add more column here to our market data. So we are using the column number 4 and 5. Okay, and what else? Okay. So to plot your diagram, we need to install this Nendo Extend. So this one can illustrate the outcome of your clustering. So we install all the necessary package, and then we say that okay, we want to have we want to cut across where we have k equal to 6 in the dendrogram, and then this is the line, the vertical line that we have. So this is the line type and the color. So the output looks like this. So meaning that okay, we have 6 cluster, right? So the color, this one based on the nil. Okay. So over here, if you want to have four cluster, we have that. If you have 6 cluster, is here. So if we illustrate this one in the real world, so for example, I go to here, then I just repeat this one. I read this one from my directory, and then I look at I just do the scaling. So now, if I look at my structure, zoom in. Okay, so if I look at my market, so we have this 5 column. Or if I type summary, so this is the additional column that I have. So I can perform the clustering. so it takes some time. So this one is the hierarchical clustering model. So I will plot that one. But first I need to install. If sometimes there'll be error because the library is no longer there. So this one is installing the Yendo extend. And then installing the necessary file for plotting. Okay, so this is the output. Okay, so we can draw a line on this line. So that is the line where the value is 0.5. So where we have six cluster there. Okay, so we need to draw the line here because if you go to the right, you have if you move to the right, you are moving towards bigger number of cluster. If you're moving to the left of that, you are moving to the less number of cluster. Okay, so this is a good visualization to look at the data. So sometimes there are more crammed data here. You look at the data is the purple one and the green one have more of point there compared to the red one here. Okay? So anyway, that is how the hierarchical clustering works, is by merging the individual item to form bigger cluster. It's good if you want to show the taxonomy of your dataset. Okay. So I will the slide again, so you can try on your own later on. Okay. So